Hey guys, talking about probability again from yesterday's assignment, just to clear up some things, and I did put you in a spot where you're supposed to think about stuff and try to figure it out. Two dice. You roll one, and these are the possibilities you can get. You can get a 1, 2, 3, 4, 5, or 6. Roll the other one. You can get a 1, 2, 3, 4, 5, or 6. Add them together, you're going to get certain numbers. Highest number you can get is 12, a 6 and a 6. Lowest number you're going to get is a 2. I threw trick question in there to find out what's the probability of getting a 1 with 2 dice. 0. Trick question. All right. Here's how you figure out the probability. The probability as a fraction is always a number of the possibilities of that event happening over the total number of possible outcomes. Outcomes for the fancy term, I have it right here. Total possible outcomes. So the number that's the top number is what could happen, or how many times what you want to find out about happens, and then the bottom number is the total number of outcomes. So if I wanted the probability of a 2, I'll back up a little bit. How many possible outcomes are there? There's 36, because you can have 2, and then you can have a 3 and a 3. Because it's 2 and a 1 and a 1 and a 2. Now, the dice matter. So if you have one die, roll 1, it's a 1, and then the other die is a 2. If you roll it again, the second die is a 2 and the other one's a 1. So if we were going to do this at school, I would give you like a green one and a red one so you can keep them separate. The part that always bugged me or I didn't quite understand is like, well, how can it be both like a 5 and a 5? Isn't it a 5 and a 5 and there should be a 5 and a 5? It's like, no. When they're the same, it doesn't matter. So that kind of changes those things. So the possibilities are 36 different ones. You could get a 1 and a 1 is a 2, and a 1 and a 2 is a 3, and so on. It goes up because a 1 and a 6 is 7. And then you kind of work your way down, and a 6 and a 6 is 12. 36 possibilities. Now I ask you the question, like, what's the experimental? The experimental would be what you found out. The theoretical would be what should happen. Now, it doesn't always happen. Now, I'm going to stress this one really big because a lot of people got confused on this one. Experimental is what happens when you try it. You do the experiment. Doesn't necessarily mean that it's supposed to be that way. It's what happens. Like if we did a spinner and one of the questions was, it was one time out of 12 and it was only 4 spots on the spinner. It should have been 1 out of 4. So if you did it 20 times, you should have had 5. But that doesn't always work that way because it's the experimental. If I flip a coin, 2 possible outcomes, heads or tails. So the bottom number would be 2. If I wanted to get heads, I get 1 chance out of 2. So the probability of getting a heads would be 1 out of 2. But I could flip a coin 10 times and get 10 heads. But it shouldn't be. I should be getting 1 out of 2 times heads. So it should be 5 tenths. It should have been 5. And 5 tenths for the other one. So if I flipped a coin 10 times, I should get heads 5 times and tails 5 times. I can get heads all the time. I can get tails all the time. I can get any different combination because that could happen in experimental probability. But the more you do the trials, the closer it should get to the experimental. I'm sorry, I said that wrong. The more you do the trials, the closer the experimental should get to the theoretical. Okay, back with this one. 36 different possibilities. Some are more likely than others. And the reason they're more likely as others is because they have more possible ways of it happening. The one that happens the most is 7, because 7 can be a 1 and a 6, can also be a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. So of these, the probability of a 7 would be 6 out of 36. Why the 36? Because that's how many total possible opportunities or total things that can happen. Those are the total possible outcomes. everything that's possible, 36 of them. And that's why I had you roll the dice 36 times. Hopefully that makes more sense. Just a couple more of these probability ones just so that we get it. So the probability of a 5, this theoretical probability of a 5, 36 opportunities, 36 outcomes. And how many would be a 5? 1, 2, 3, 4. 4 chances. It's 4 out of 36. Usually write it as a fraction. You can write it as a percent or a decimal too. And that just becomes 1/9 if you wanted to simplify. Probability of a 3. There's only 2 of them. It'd be 2 out of 36. The probability of a 12. 1 chance out of 36. And those are all the theoretical probabilities. In yours, when you roll the dice or you use the website to do it, some were close. I looked. Some were close. Some were pretty far off. But most of you kind of like, oh yeah, it's kind of these middle numbers because there's more opportunities. That's how that works. And the probability of me coming up with some kind of an extra credit thing is 100%. Because this guy right here, this is Vincent van Gogh. Now, Vincent van Gogh, he fell down there, was a famous painter he was Dutch, and he was my favorite all-time painter, all-time artist. And he actually has some of his art, 2 of his paintings are up in Winona, and these are $4 or $5 million paintings. He really never was rich. His paintings weren't really looked on until later on. But anyway, he had some mental illness issues, and he ended up cutting his ear off. And he did it to get attention for a girl. So when Jessie, in one of our things, she said, "This is Van Gogh." And he says, "Don't play with sharp things. Don't play with sharp objects." That was her joke, and I don't think anybody got it. But that's because when he was later in life, he ended up cutting his ear off to try to get attention from a girl. Put in Van Gogh or Vincent van Gogh in your comments, and you get extra credit point. I have a new board. For today, we have what we're doing with probabilities, and we're going to put it 2 separate events. They're independent events. They're events from each other, and we're going to find the probabilities of those. And it's pretty easy. All you really have to do is you find all the possible things that could happen. And if I have a spinner and it's even, let's say it's even, I have a 1 in 3 chance of getting red, right? 1 in 3 chance of getting blue, and 1 in 3 chance of getting green. And then I'm going to do that, and then I'm going to flip a coin. So we just need to figure out what our possibilities are. So in the spinner, I might get red. I'll just do it right here. And if I get red, I'm going to flip a coin. And I only have 2 possibilities I can get from that. I can get a heads and I can get a tail. Okay. Spinner, I get blue. Then flip a coin. I can get heads or tails. Spinner, green, heads or tails. Now those are all my possibilities. So if I wanted to do these would be called, like these would be my outcomes. And I could have sample space, the things, it's called the sample space. But what are the possibilities? I could have a red and a head, red head, red and a tail, a blue and a head, and a blue and a tail, and then a green and a head, and a green and a tail. How many total possible outcomes do I have? 1, 2, 3, 4, 5, 6. I have 6. So 6 outcomes. Now what's my probability of getting a red head? 1 out of 6. So the probability of a red and a head is 1 out of 6. Because there's 6 chances. That is the theoretical again. That's what's supposed to happen. Could we do it and they all end up being redheads? Yeah, it could happen, but most likely not. And the more times you do it, the closer it's going to get to where each one has an equal chance of happening 1 out of 6. That is how you determine the probability of that, and this is the outcome sample space. Ha! Another whiteboard. In this case, I would have a coin and then dice. So I have a coin and then dice. My possibilities for the coin would be heads or tails. The dice would be 1, 2, 3, 4, 5, or 6. Now, if I put them together, they're separate things, they're independent things, but I have to do one then the other. What are my possible things if I flip a coin first, and then after that, I'll roll a dice? Here's my chances. I could have a heads and a 1, a heads and a 2, heads and a 3, heads and a 4, heads and a 5, and a heads and a 6. And then for tails, I could do tails in a 1, 2, 3, 4, 5, or 6. So my sample space, which is also going to tell me my possible outcomes, it'll be 12 different things. Because I can have a head and a 1, a head and a 2, a head and a 3, so those are all the possible things that I have. So if my chances of getting a head and then a 1 would be 1 chance out of the whole thing. So my total outcomes are 12. This is everything that could happen. Everything that could happen. My total chances or things that could happen are 12. And then what I want, if I want a heads and a 1, I would say there's 1 chance out of 12. What are my chances of the tails? It's 1/2 of it. But any of these things, this is going to be your sample space, which will tell you the outcomes. And the number of outcomes is going to be in the bottom. Hi, and yet another dry erase board. Anyway, in this situation, I have 4 cards and a spinner. So when I do a problem like this, it asks me, well, what are the probabilities? What's the sample space? What's the chances of maybe getting a 1 and then a purple? To figure those things out, you just make a chart, just like we had before. You'll be asked to do this in the assignment today. So you're just making a chart, and chart would look like this. It's like different possibilities. So if I get a 1, my possibilities are after a 1, so I draw a 1 out of these random, it's 1 out of 4 chance. Then I take a look at these, and I was like, okay, well, I can get a 1 with a red, or I can have a 1 with a purple, or a 1 with a yellow, or a 1 with an orange. So my chances are a 1 card with an R, a 1, a P, purple, a 1 yellow, and a 1 orange. Next chance would be with a 2, and I don't know, I'm just picking colors because I bought all these new ones, so I just want to use them. Alright, so then same thing, R, P, Y, yellow, and an orange. And my possibilities are 2 red, 2 purple, 2 yellow, and 2 orange. Next chance I have is a 3. So if I have a 3, same thing. It's going to have a red, purple, yellow, orange. So it would be a 3 R. And then finally, all right, so then that's how we do it. This is the sample space. All the possibilities, that's what it means. All the possibilities. And then I made it out, I made it into a chart. So these are separate events, doesn't depend on each other. If I have a 1, then it's there. And then I just have to find out the probability of any one of these events to happen. It's the number that I have. So if I want to find out to get a 2 and then a red, so draw a 2 and then a red, I would have this chance. No, it's going to be R. This chance. But, so I'd have 1 chance of doing it. I'm just write probability of a 2 and an R is 1, but then how many total possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 1 out of 16 chances. So 1 out of 16 chances. And that's your probability. That's a theoretical probability if you have 2 different separate events that are independent of each other. That's how you do the assignment. It's not too bad. first situation is that if you have A, you can have either of the 6. If you have B, either of the 6. Okay, so, but I'm not done because I still have to flip a coin after that. I'll show you what that looks like. Now I've filled those in, and you'll see that if you have a possibility, if it's A, you also have a possibility like a 1 and then a heads. Or you could have an A, a 1, and a tail. A 6 and a heads, or A and a 6 and a tails. And it gives you all these different possibilities, and this is your sample space, which are your possibilities. And I'll write those out now. That's all of the possibilities. So there are lots of possibilities when you have 3 different events. You just have to make them into these charts. You just have to break them down and show. So then this is my sample space, everything that's possibly could happen. And then to find out if a certain situation is, you have to know how many total outcomes there are. And in the total outcomes, there are 24. 24. So if the chances of it being, if I get this situation, the chances of getting an A, a 1, and a heads would be 1 and 24. So the probability of A, 1 heads is 1 in 24. Theoretical probability. Will it necessarily happen 1 out of 24 times? I don't know. It's experimental. Anything can happen. But the more times you do it, it should work out like this. The situation that you have, you might be asked something about like what happens if there's a game. What if I would win if I have an odd number and a tails? So you just have to go through and figure out which are the odd numbers and the tails. Okay, so here's an odd number and a tail. Here is, and there, and then an odd number and a tail. Odd number and a tail. Odd number and a tail. So those are the possibilities that you could get an odd number and a tail. So it'd be like 1, 2, 3, 4, 5, 6. So what's my chances of getting this if this is a situation? The probability of getting an odd and a tail would be 1, 2, 3, 4, 5, 6, and out of my 24. And so my probability is it's a 1 out of 4 chance. That's how you sort those out. Today, I'm just going to turn this a little bit. Your assignment, pretty easy compared to what we've been doing before. You just have page 737, 1 through 6, and then 739, 11 through 13. No IXL. Make sure you're catching up. Some people were a little bit behind from yesterday. Make sure you have those all. And when you have IXLs, you have to take a screenshot and then show it to me. And make sure you've done if you're at 80, you need to have at least 30 questions. All right, get to work, go.